All right, hello everyone, and welcome again to another one of Mr. Martin's math videos. This is a video for British Columbia Math 9, looking at Chapter 6, which is all about solving linear equations, Section 1.2. So solving these equations. Now we're moving from one-step algebraic equations to two-step equations. So getting a little bit more complex here. But again, our two objectives are the same. We want to model problems with linear equations involving two operations and use multiple strategies to solve these linear equations with rational numbers using two operations. And so important things to remember from last video that we made. One is that equations are mathematical statements that equate two expressions with an equal sign. So whatever is on the left side is equal to whatever is on the right side. The left side must always equal the right side, even though the left and right side may change based on the operations we do. They must still equal each other. Okay, the equation must remain true. The goal of algebra is to isolate the variable so that as to solve for the value of the variable, because if you just have x is equal to something, then you know the value of the variable by doing so. And balance is extremely important. Remember that whatever we do to the left side of the equation, we have to do to the right side of the equation and vice versa. All right. So with these two under our belts, these five under our belts really, we're going to look at some slightly more complicated equations today and develop strategies for how to solve them. Okay, so here the example one, solving two-step problems. The following equations, I'm going to show you two different ways to solve these problems. Okay, all right. So here, what the left-hand side, right-hand side approach here. Sometimes it's helpful to kind of see the line separating the left-hand side and the right-hand side. So I'm going to write the equation kind of on either sides of this box so we can follow what the left-hand side and the right-hand side is doing. Okay, left-hand side, right-hand side. Okay, so here the point of algebra is I'm trying to find the value of x, and I do so by isolating the variable for x. Okay. Now, we've talked about how when you're doing algebra, the way I get rid of, for example, the plus 9 and the 4, okay, is I'm going to use the opposite operations to get rid of those terms. And I'm going to use the opposite operations on both sides of my equation, okay? And you'll see why we use the opposite operations on both sides of the equation. All right, so let me clean that up here. Also, when it comes to your order of operations when you're solving algebraically, you're doing the opposite of BEDMAS. Okay, if you remember the order of operations, brackets, exponents, division, multiplication, addition, subtraction. Okay, when you're doing algebra, you're doing the opposite of BEDMAS. Okay, you're doing Sam Deb. Okay, where you want to take care of the plus minus first, and then you take care of division, multiplication, and then exponents, and then brackets. Okay, so your algebra is actually the opposite of your order of operations when you're solving an expression. All right, so that means, so the first thing I want to do here, and I'll kind of show you why here. So here, whatever I need to get rid of the 4, okay, and the 9, okay? If I try to get rid of the 4 first, I have to divide the entire side by 4, okay? Which is fine for here, right? This works out okay. But then I also end up with this fraction on the left side, on the right side there, okay, and a fraction over here. And things get messy really quickly, all right? And so a way to kind of keep things simple is by exactly what I just said, that we want to do the addition, subtraction first, and then we'll do the multiplication, division, and then if there's exponents and brackets, we'll take care of those at the very end. Okay, so here to get rid of the 9 on the left-hand side, I want to make my constant here, which is the number without a variable, equal to 0. okay? And so if I have positive 9, how do I make that equal to 0? I'm going to subtract 9, and whatever I do to one side, I have to do to the other side. So minus 9, minus 9. What does that give me? That gives me, and here I'm going to do an extra step you don't have to do, but I just wanted to show you guys why the opposite operation works as it does. Why can we cancel things out when we do opposite operations? Because here I end up with 4x plus 0, right? That's what happens when I subtract 9 from 9. I end up with 0, okay? And on this side, I end up with negative 20. Okay? Now, if it's 4x plus 0, I don't have to put the 0, so I could rewrite this as just 4x is equal to negative 20. Okay? So in essence, because I've used the opposite operation for this plus 9, by subtracting 9 on both sides, I've canceled out the 9. Okay? And I've simplified my equation. Okay? And again, you don't have to do this middle step here. This middle step is optional. Okay? That plus 0 thing. You can go move here directly into here after you've canceled out that 9. Okay? Now I'm going to do the same thing to the fourth. Now, I don't want that 4 to become a 0 because 0 times x is 0. So I've not isolated my variable if I do that. I've actually eliminated my variable, which I don't want to do. And I couldn't make this 0 even if I wanted to. If I divided by 0, I'd get undefined. And so, so here, because it's 4 times x, okay, I'm going to divide both sides by 4. Okay, well, what's that going to do? 4 divided by 4, 4 over 4 is equal to 1. So that's going to give me 1 times x is equal to, and then negative 20 divided by 4 is negative 5. Okay? So 4 over 4 is equal to 1, right? And that's what I want with a multiplication. I want the number to equal 1 because 1 times x is equal to x. Okay, and once I get to x is equal to just one number on the other side, I've solved for my equation. In this situation, x is equal to 5. All right. Okay, so this, I wanted to kind of, the 2 extra steps that I've kind of done here just to show you guys what's happening are the 2 yellow highlighted steps here. Okay. These are the 2 steps that you don't have to do, okay? When I cross out the 9, plus 9 minus 9 equals 0, I don't actually have to write plus 0, right? I just wanted to show you guys that's why using the opposite operation cancels that 9 out, is because 9 minus 9 is equal to 0, and 4x plus 0 is equal to 4x. And so, it just kind of eliminates itself. Same thing here, okay? Here, 4 times x, but here I'm not trying to get that 4 to 0. I want it to be a 1 because 1 times x will give me x. So I do 4 divided by 4. So 4 over 4 is equal to 1. It's equal to 1 over 1, which is equal to 1. Then 1 times x is equal to x. And so in essence, the 4x divided by 4, the 4's cancel out. Okay? And then I'm left with x is equal to negative 5. So really, you only have to show those steps that aren't highlighted. Okay, typically, and kind of from after these 2 example questions, I'm not going to be showing those yellow highlighted steps. We're just going to move from the top step, follow the red arrow to the middle step, and then have our final answer there. Okay, so these are just 2-step problems. Okay, another way you could solve for this equation is by graphing, okay? If you have a graphing calculator, where you can kind of use the internet, desmos.com or something like that, it can allow you to solve for various equations and plugging equations. And so to use this, I would put in what my left side of the equation into y1. Let me just write that out here. So for graphing, I would put y1 is equal to the 4x plus 9, okay, because that's on my left side. and then y2 in my graphing calculator, I'll put to negative 11. Okay, so 4x plus 9, and then negative 11. Okay, when I graph that, you'll be able to, if you do this on a computer, see where the two lines cross is my answer. Because that's when the left side, or the green line, is equal to the right side, or the yellow line. So where they are equal to each other is where the lines cross. And if you're using a computer, you'll just be able to click on that point of intersect, and then you get your answer here. You'll notice the x is equal to negative 5. It's right there. Okay, so that's another way that you can solve this problem. Okay, is by utilizing graphing. All right, let's try another problem. This problem here. Okay, again, I'm going to use that solid line to separate my left side of the equation from my right side of the equation. I have k over 4 minus 19 is equal to negative 15. Okay, again, my variable that I want to isolate is on the left-hand side. So I'm going to move that negative 19 to the right and that divided by 4 to the right as well. Okay, so I'm going to start with my negative 19. All right, here negative 19. Since it's minus 19 and I want to cancel it out, I'm going to plus 19 on both sides. Okay, I'm doing the opposite operation because I want negative 19 plus positive 19 to equal 0. Okay, which it does, right? So I end up with k over 4 plus 0. And again, this is an extra step you don't have to do, but I really want to show you that, guys, that. And then this gives me is equal to 4. Okay, negative 15 plus 19 is 4. Okay, and because that 0 is, this optional step here, that k over 4 plus 0 is just k over 4 is equal to 4. Okay, next, okay, so in essence, this 19s cancel each other out there because of opposite operations. Okay, next, here I have k divided by 4. Well, if addition is the opposite of subtraction, subtraction is the opposite of addition, and we say that division is the opposite of multiplication, therefore multiplication is the opposite of division. Okay, and so here, because it's divided by 4, I'm going to multiply 4 on both sides. Okay, well, what does that give me? Well, here I end up with, I use a different color. Here I'm going to end up with 4 over 4. And I already saw here with those exact numbers, 4 over 4 equals 1, right? So this is going to create 1 times k is equal to 16, which, again, that's an extra step because 1 times k is k. So it essentially just gives me k is equal to 16. All right? So these are the steps. Those yellow steps are kind of optional steps. I won't be doing those steps moving forward. Okay, but I just wanted to show you guys that so that you can kind of see why do we use those opposite operations. Why do they work for algebra? The reason is because they cancel out the numbers by either giving us a 0 if the number is not multiplied to a variable, or a 1 if the number is multiplied to a variable. Okay? And then we end up with an isolated number. Similar situation for graphing. Okay? y1, I'm going to enter k over 4 minus 19. y2, I'm going to enter negative 15. Okay? Put that in my calculator. So this is x divided by 4. Okay, in your graphing calculators, typically you don't have option of lots of variables. You just use x every time. There are ways to get other variables, but you can just use x. And then minus negative 15, not minus 15. And then I graph, and then I see my two lines. Okay, and again, where x over 4 minus 19 is equal to negative 15 is when the two lines cross each other. Okay, and they meet right here. and they meet when x is equal to 16, okay? Or in this case, k is equal to 16, which is what we saw when we solved it algebraically. Okay? This is your turn here. I'm going to do one with you, okay? Just the first one, just so that you can see me do these questions without adding that middle highlighted step there that I did above, okay? And then the other three I want you guys to do afterwards. So let's do this first one together, okay? Again, I want to start with the plus minus, and then I go into division multiplication, okay? So it's minus 15, so I'm going to have plus 15 on both sides. All right, I know that that's going to cancel out that 15. Negative 15 plus 15 is 0, okay? And so that's going to leave me with n, and I'm going to put the negative 7, the negative with the 7 on the bottom, because I want a positive variable. That negative, you can move up or down. It doesn't matter, okay? So here I'm going to put it down because I want a positive variable isolated in the end, okay? And negative 18 plus 15 is equal to negative 3, all right? So that's first step, all right? Second step is because it's n divided by negative 7, I'm going to multiply negative 7 on both sides. All right? And here I know that negative 7 divided by negative 7 is equal to 1, and 1 times n is equal to n. So these cancel out. I'm left with n. The negative 3 times negative 7 is equal to positive 21. Okay, and that's how your work would typically look. Okay, you don't have to have 5 different steps. You just have to do a 2-step problem, and then you're done. Okay, go ahead and pause the video, finish off these other 3 questions, and then we'll do it all together. All right, hopefully that went well for you. Excuse the car alarm that's going off in the background. I'm sure someone will stop that soon. So here, let's do this next question. Okay, this next question, they're trying to trick you a little bit because the variable now is on the right side instead of the left side. It does not matter which side the variable is on. You isolate it on the side the variable finds itself in. So I'm going to isolate it on the right side. So I'm going to start with that 24. It's positive 24, so 24 minus 24 is going to equal 0. Okay, and whatever I do, hang on, put that in red. So minus 24 minus 24. Okay, and whatever I do to one side, I have to do to the other side. Okay, that's always have to do that. 24's cancel out. And I'm left with negative 45 is equal to 5p. Right? All right. And the next step, 5 times p. So because it's 5 times p, I'm going to divide by p. So 5 divided by 5 is equal to 1. 1 times p is equal to p, right? So I essentially canceled out the 5s there. And whatever I do to one side, I have to do to the other side. All right? And so that cancels out. I'm left with p. And then negative 45 divided by 5 is negative 9. Okay? Let's try another one. Again, started with the negative, the minus, plus minus, opposite of order of operations is kind of the direction you want to go here. All right, so here it's minus 18. So I'm going to add 18 to both sides, plus 18, plus 18. That's going to give me t, and I'm going to put that negative in the denominator, okay, because I want a positive variable left at the end. Okay, those 18s cancel out, and I like to actually physically cross them off just so that they're gone, and they're visibly gone, and it's also satisfying, not gonna lie. And then, but I do also want you guys, I want to see you guys write the 18s on both sides, okay, because I see students making silly mistakes. I still write them, even with, pre-calc 12 questions, grade 12 math, I still write my numbers and whatever I do on one side on the other side, just so I don't lose anything along the way. Okay, because these problems get more and more complex, and you have a greater and greater chance of losing numbers along the way if you don't take care, to do your work in an organized and efficient manner. Okay, negative 27 plus 18 leaves me with negative 5 on this side. All right. Now it's t divided by negative 5, so the opposite operation of division is multiplication, so I'm going to multiply negative 5 on both sides. Okay. Negative 5 divided by negative 5, or negative 5 over negative 5 is 1, and 1 times t is t, so they essentially cancel out. I end up with t. Negative 5 times negative 5 is positive 25, and that's the solution for that question. Okay, last problem here. I have negative 7x minus 23, so I'm going to add 23 to both sides. So minus 23 plus 23 is equal to 0, therefore effectively canceling out the 23's, leaves me with negative 7x. All right, and negative 73 plus 72 plus 23. If you're not sure, plug it into your calculator, negative 49. All right. And then last step here, negative 7 times x. So I'm going to do divided by negative 7, and whatever I do on one side, I have to do to the other side. And then that negative 7 over negative 7 is equal to 1, and 1 times x is equal to x. And so they essentially eliminate each other. I'm left with x. Negative 49 divided by negative 7 is equal to positive 7. All right? Hopefully that went well for you. Rewatch anything if you're not sure, if you made a mistake along the way. Make sure you understand why you made that mistake. Okay. Now let's try a different kind of problem here, but now these ones deal with fractions. Okay. And so here, and this wording should be down here. So just kind of ignore it's there. Okay, so here we have this question here, but it's similar steps here. We're just dealing with fractions instead of, not fractions. All right, so let's give this a try here. So 2x, so my variable is right here, right? That's where I want to isolate. That's what I want to isolate right there. I start with plus minus, then division multiplication. So here I want to minus and leave things in fractions. Don't change things to decimals and then go from there, because if it's over 5 or over 4 or over 10 or over 2 or something, then you get a terminating decimal. And so you can get away with it. However, once you get like a number over 3 or over 6 or over 9, then you get the over 7, you get these messy long decimals that you're going to end up rounding them, and your answer is not going to be as exact as it could be. Okay, so when you're given fractions, I expect answers in fractions. Okay, even if you hate fractions. Okay, so this is another time for you to brush up on your fraction skills, or to acquire those skills if you have not done so, enough. All right. Again, when you're doing these problems, you want to imagine that, kind of that line between the left-hand side of the problem and the right-hand side of the problem. You'll notice in my questions, I try to kind of keep that equal sign at the same place throughout the question, so that without even, trying to, my left-hand side is clearly defined from my right-hand side. Okay, so when I do things on one side, like add 23, I clearly do it on one side and the other side of my equal sign. That's the dividing line. Okay? There's to the left of the equal sign and to the right of the equal sign. So when I subtract 10, I subtract it to the left of the equal sign and to the right of the equal sign. Okay? Positive 1 over 10 minus 1 over 10 is going to give me 0. Okay, so they effectively cancel each other out, which leaves me with 2x. Okay, is equal to. Okay, now some of these fraction work, it might be a good idea for you to kind of do it on the side. So here, for kind of, this is like a bracket work. I have 3 over 5 minus 1 over 10. Okay, I need to add like common denominator. This is my side work when adding fractions or subtracting fractions, or multiplying or dividing fractions, those kinds of things. You can do your work on the side like this. Okay, so here I need common denominators to subtract fractions, so I multiply both the top and the bottom of this one by 2 to get a common denominator of 10. I end up with 6 over 10 minus 1 over 10, which is equal to 5 over 10 which is equal to 1 over 2. All right, so that's my, so 2x is equal to 1 over 2. All right, and the next step here is 2 times x is equal to 1/2. So because it's 2 times x, I divide both sides by 2. All right. And that's going to leave me with, because 2 over 2 is equal to 1, 1 times x is equal to x. So they effectively cancel each other out. Okay. Now here, all right, when you're dividing a fraction, even if you're dividing a fraction by a whole number, it's helpful to see this as not, the denominator is not 2, but you're dividing by 2 over 1. Okay, so, another side calculation here that you're doing is 1 over 2 divided by 2 over 1. And in order to divide fractions, you're going to multiply by the reciprocal. So it's 1 over 2 times 1 over 2, right? You're going to multiply by the reciprocal, which is equal to 1 over 4, which is what x is equal to. Okay, and I want to circle your final answer so it's clearly seen. All right, so again, I suggest that you do your kind of fraction work on the side, and then plug in your answers from your fraction work into your algebra kind of workflow. Okay, like I did here. Okay, let's try another question together. Well, I don't know why that's C and B here, but I'm just gonna I'm going to do B, and then you guys do C and D. That's what we're going to do. Okay. So B here, again, k over 3 minus 1/2 is equal to negative 1 and 3 over 4. So I'm going to change that to an improper fraction along the way as well here. But I'm going to start with my first step in algebra, which is adding 1/2 to both sides of the equation. All right. Because negative 1/2 plus positive 1/2 is equal to 0, these cancel out, and I end up with k over 3, okay, on the left-hand side. On the right-hand side, I'm going to do some side work. Okay, here, first thing I want to do is change my mixed fraction into an improper fraction. So negative 1 times 4 is negative 4, minus 3 is negative 7 over 4. Okay, so that's what my mixed fraction is. Okay, and then I'm going to do negative 7 over 4 plus 1/2. So here, common denominator, I need to multiply 2 on the top and bottom. That's going to give me negative 7 over 4 plus 2 over 4, which is equal to negative 5 over 4. So that's what I get over here, negative 5 over 4. Okay, all in that side work. All right. Now, here, because it's k divided by 3, the opposite operation of division is a multiplication. So I'm going to multiply 3 on both sides. Okay, or again, because it's a fraction, you can multiply 3 over 1 on both sides. Okay, the 3's cancel out because 3 over 3 is 1. 1 times k is k. So I'm left with k by itself. And then here I'm multiplying fractions, but it's just top times top and bottom times bottom, right? And so here it's negative 5 times 3 is negative 15, and 4 times 1 is 4. Okay? And then the last step, you can change that into an improper fraction, all right? So if you remember improper fractions here, if you do negative 15 divided by 4, 4 goes into negative 15, what is that, 3 times? Okay, negative 3 times, which gives you negative 12, which leaves you with a remainder of 3 in the denominator. Okay? So this gives you negative 3 and 3 over 4. Okay? So that's the improper fraction answer and the mixed fraction answer there. All right? Go ahead and pause the video and give this a shot on your own, and then unpause the video. We'll come back together and work on it. All right, hopefully that went well for you. Let's answer C and D together. C, okay, again here, I start with plus minus, then I do division and multiplication. So here it's plus 1/2, so I'm going to subtract 1/2 on both sides of my equal sign, right? My equal sign, this is my left-hand side of the equal sign, right? This is my right-hand side of the equal sign. So I have to do it to both sides. Here, positive 1/2 minus negative 1/2 is 0, so these cancel out. I'm left with 2y, all right? And then I'm going to do some side work, okay? And I got 3 over 4 minus 1 over 2. Common denominator, I need to multiply top and bottom by 2. I get 3 over 4 minus 2 over 4 is equal to 1 over 4. So I plug that into my algebra. All right, next, 2 times y. So here, because it's 2 times y, I'm going to divide both sides by 2. All right, 2 over 2 is equal to 1. 1 times y is equal to y, so they essentially cancel out. And then here, again, the side work, this would be 1 over 4 divided by 2, but you can see it as 2 over 1, right? Because it's helpful to see it as a fraction when you're dividing a fraction. And then you can change this to 1 over 4 times the reciprocal, 1 over 2, which gives me top times top, bottom times bottom, gives me 1 over 8 as my final answer. Okay? Notice when I do the division at this step here, I always make my division line longer than the fraction line that I'm dividing. That kind of helps group my fractions accordingly, okay? Because here, if you do like 1 over 4 over 2, it kind of messes you up in your fraction. Though at the same time, it doesn't matter how you write it. Actually, no, it doesn't matter how you write it. So, yeah, so you kind of want to, that's a trick for it to help kind of sort out your fractions here, to draw this line longer than the line in your fraction there. Okay, just a little pro tip there. Okay, and last question here. We'll get it started again. I'll have to turn that one into a mixed or improper fraction. Do that in a second. First, I'm going to add 3 over 4 to both sides of the equal sign. All right, that's going to cancel out the 3 over 4 because together they equal 0. So that's going to leave me with n over 2 is equal to, then I need to do some side work. Side work for my fractions. And so here, first 2 and 3 over 8 is equal to 16, 19 over 8. Okay, so I have 19 over 8 plus 3 over 4 from my algebraic step. So I'm going to get common denominators here. That's going to give me 19 over 8 plus 6 over 8, which is equal to 25 over 8. So I end up with 25 over 8. Okay, here there's 2 steps you could do here. You can divide, you can multiply both sides by 2, or you can cross multiply. I think here the easiest step, honestly, I won't do cross multiplication. I'm just going to stick with the opposite operation. So it's n divided by divided by 2. So I'm going to multiply 2 on both sides. Okay, 2 over 2 is equal to 1. 1 times n is equal to n. So that cancels out the 2's. I'm left with n. And again, here I'm multiplying 2, or you can see it multiplying as 2 over 1, right? Any number can be over 1, written over 1. And then you're just multiplying top times top, bottom times bottom. And so 25 times 2 is 50 divided by 8 is my answer for this fraction. And then here I can come up with a more simplified mixed fraction here. And so here this would be 48 is 8 times 6. So it would be 6 here, let's just do the work on the side work again over here. 50 over 8, and then 6, that gives me 48, leaves me with a remainder of 2. Okay, so that gives me 6 and 2 over 8, or 6 and 1 over 4 if I reduce that fraction. Okay, so n is equal to 6 and 1 over 4. Okay? So yeah, lots of steps here when you get into fractions, but the steps are not new. It's just longer and maybe more tedious. But you know how to deal with fractions. And again, I suggest that you do the fraction steps as side work apart from your algebra steps. Okay, that'll help keep your algebra clean, and it'll help to kind of keep your fraction steps clean as well. Okay, so you want to kind of do side work to the side when it comes to you dealing with your fractions. Maybe I should have done that. So it doesn't, kind of get in the way of your algebra work. Okay, kind of keep them separate. That'll help it out. All right, last couple questions here. We're dealing with word problems and turning them into equations and then solving those equations. Okay, so we have to be able to figure out what the equation is in the word problem and then how to turn it into an equation and then solve that equation. So here, Colin has a terrible long-distance phone plan that charges 5 cents per minute for long-distance calls within Canada. Yeah, gone are the days. There's also a monthly fee of $4.95. 1 month, Colin's total long-distance charges were $18.75. How many minutes of long-distance calls did Colin make that month? All right, so here we're looking for an equation that gives us the total cost of a phone plan per month. Okay, and we know that the total cost of his plan is $18.75 for that month. All right, and we also know that there's an initial fee of $4.95, and then on top of that, he has to pay 5 cents or 0.05 for every minute that he uses. And then they want to know how many minutes. What is the value of M? That's what they want to know. Okay, so I have the initial amount, okay, plus the rate of change. Okay, you'll notice this language from last chapter. But the difference with this chapter is that it's now equal to something. All right, so all of the steps are there. Okay, so again, I want to start with addition, subtraction, then multiplication, division. But I'm just working at regular algebra steps. So $4.95 minus $4.95 on both sides. That makes sense, right? Because if you want to figure out how much minutes he spent, first you have to account for that $4.95 that he's paid. So $4.95 minus $4.95 is equal to 0, so they effectively cancel out, and I'm left with 0.05. M is equal to 18.75 minus 4.95. So then only $13.80 was because of his phone calls. Okay, $4.95 was that regular monthly fee. All right, last step. Because it's 0.05 times n, I'm going to divide both sides by 0.05. All right, 0.05 over 0.05 is equal to 1. 1 times m is equal to m, so this effectively gets canceled out by opposite operations. I'm left with m. And then I divide the $13.80 divided by 0.05 cents for every minute gives me 276 minutes. Okay, now here with these questions, you want to include your units. Okay, it's not 276 orangutans or 276 kilometers an hour. Okay, it is minutes, and it needs to be clear in your answer. Okay, let's try another one. Julia and Mike are saving to buy their TV, their own TV. Julia has saved $250. Mike has saved $180 each week. Julia adds an extra $40, where Mike adds an extra $70. If the TV they are trying to save for costs $600, who will be the first person to be able to afford the TV? All right, well, Julia has an initial amount of $250, so more than Mike, but she only adds $40 per week. Okay, and we want to solve the week which they can buy it, okay, because that's going to tell us who can buy it first. And that is equal to $600. Okay, this is for Julia. All right, so we can solve this algebraically real quick here. Minus 250 on both sides for that initial amount. That gives me $40 per week to make up the last $350 left on the TV, or left to buy the TV. And then because it's 40 times W, I'm going to divide both sides by 40. That cancels that out. I'm left with 350 divided by 40, which is 8.75 weeks, or 9 weeks, because she's not going to put that last $40 until the end of the week, okay, is what we can assume. So that's Julia. Ooh, I've taken up the whole page for Julia. Now let's solve for Mike. I'll solve for Mike over on the side here. Okay, Mike. Mike starts off with less money, $180, but he's adding $70 per week. And he needs to buy that same $600 TV. Okay, my steps here will be in blue. I start off by subtracting the initial amount he had saved. That cancels out. I'm left with 70W is equal to, what is this, 420. And then divide both sides by 70 week, because it's 70 times W. So I'm going to divide both sides by 70. That cancels that out. I get W is equal to 420 divided by 70, which is 6. 6 weeks exactly. Okay, so Mike is going to get the TV before Julia. And this also highlights an important truth in finances. If you want to save money, yes, it helps to have an initial value that you've saved, like $250 Julia had versus only the $180 that Mike had. However, at the end of the day, it's the person that saves most on a regular basis, which was Mike, that's going to win the race, and not the person that saves less but had the larger initial amount. Okay? That is a very, very important truth in finance, one that I hope that you will remember. All right? That is the notes for today. Hopefully these were helpful to you. Make sure to do the checkup here. Can you model a problem of linear equations involving two operations? These last two questions, hopefully you were able to do so. And then can you use multiple strategies to solve these linear equations? So we looked at algebraically and also graphing, or those two strategies. Okay, this is your homework. Your due date is next Wednesday. If you have any questions, reach out to me either in the comments or through Teams, and we will see you next time. Goodbye.